Calculus Kids, this is Dr. Callahan with Week 16 Tuesday. How are you guys doing? Go ahead and pause the video and answer the following questions. Okay, so we're going to take a look at this free response question with a calculator that was showcased for question number 2 back in 2010 for the free response. I'm going to give you guys a second to go ahead and read the question here. It says a zoo sponsored a one-day contest and named a new baby elephant. Zoo visitor deposit entries in a special box between noon and 8 p.m., so 0 to 8. The number of entries in the box after T hours after noon is modeled by a differentiable function for E, and hundreds of entries at various times are shown on the table above. So A asks you to go ahead and use the data in the table to approximate the rate in hundredths at which entries were deposited at time t equals 6. Show the computation that leads to your answer. So if you're looking at this, you're looking at the rate of change of the entries at t equals 6. Okay. So in which case, if you're going to do that, it will have to be the changes of y over the changes of x. And so here's your x, which is hours. Here's your y, which is the number of entries. And this is going to be between So given the fact you're looking for e prime of 6, well, which two numbers here is closest to 6? Well, that's only between 5 and 7. So your respective answers and values for y is 13 and 21. So changes of y is going to be e of 7 minus e of 6 divided by 7 minus 5. There we go. 7 minus 5. So then looking at this right here with the table, you should have 21 minus 13 over 7 minus 5, which is going to give you a 8 over 2, which is 4. Now, what does 4 indicate? That 4 is going to be hundreds of entries. So you're thinking about 400 entries, or you could actually just say better yet, it's 400s of entries at t equals 6. And that is your answer. If you did answer the question correctly, it is just 1 point. It's a very simple e prime of 6 question. Second question is part B, and it says use a trapezoidal sum with the 4 subintervals given by the table to approximate a value from 1 over 8, integral 0 to 8, e of t dt. Using the correct unit, explain the meaning of e of t in terms of the number of entries. So keep in mind that your e of t represents not 0, 4, 13 entries, it's hundreds of entries. And so hundreds, think of hundreds, literally hundreds of entries. Okay. All right, so then let's go ahead and write down the formula. So 1/8 from 0 to 8, e of t dt is going to equal to 1 over 8. Given the fact that this is a trapezoidal Riemann sum, remember with a trapezoidal Riemann sum, the area is going to be, oftentimes you think of a trapezoid looking like this. Here's your height, base 1, base 2. Your area is 1/2 base 1 plus base 2 times height. Well, given the fact that your trapezoid is rotated in this situation, you have height 1, height 2, base. So 1/2 base, height 1 plus height 2. So then looking at this here, your height is going to be in this location. So your base in this situation is going to be the x value, Remember, this right here is the changes of x's. This one's changes of y's. And this is going to be your height. Okay, so let's take a look to see what that's going to be. From 0 to 2, the height changes 2. 2 to 5, 3. 5 to 7, 2. 7 to 8, 1. Now, with this trapezoidal, you have two heights, height 1, height 2. So here's your height 1 and height 2. You add them together because there's a plus sign in between them. So you have a 4. Same thing over here. If you add these two together, this is going to be another height 1 and height 2. If you add it together, it's going to give you a 17. Then you have another height 1 and height 2 for the third trapezoid, which in this situation is going to give you 13 and 21, which is 34. And then your fourth height or fourth trapezoid reiman sum, 21 and 23, you add them together, which is then going to give you a 44. And so if you look at this right here, this 4 represents the first trapezoid. 17 is the height of the two trapezoids in trapezoid 2, trapezoid 3, trapezoid 4. All right, so then 1/8. Your first trapezoid, trapezoid 1, is going to be 1/2 base. The base is going to be 2 times height 1 plus height 2. Height 1 plus height 2 is 0 plus 4, which we established is 4. Plus trapezoid 2, which is 1/2 base. The base for trapezoid 2 is going to be between 2 to 5, and that's 3. And then height 1 plus height 2. Trapezoid 2, height 1 plus height 2 is 4 plus 13, which is 17. Plus 1/2 the base of trapezoid 3, which is 2, times the height 1 plus height 2 of trapezoid 3, which is 13 plus 21, that's 34. Plus the last trapezoid, so that's 1/2 base, that base is 1, times height 1 plus height 2, and that's 44. So with your calculator, go ahead and calculate that, which should give you 10.689. So then we have to go ahead and explain this with the meaning. So what you can say is, you can say 1/8, the integral from 0 to 8, e of t dt is the average number of hundredths of entries in the box that's naming the elephant, between noon, which is when t equals 0, and 8 p.m. when t equals 8. If you would describe it that way, take a look at part B. It is worth 3 points. And if you look at the 3 points, 1 point for the trapezoidal sum, approximation, and then justifying your answer with the meaning. Part C. At 8 p.m., volunteer began processing the entries. They processed the entries at a rate modeled by P of T, hundreds of entries per hour between 8 to 12. Because the entry stopped at 8, so they're doing this from 8 p.m. till midnight. According to the model, how many entries had not yet been processed by midnight by t equals 12? So essentially what it's asking is how many entries are unprocessed by midnight when t equals 12. Well, they're processing this at 8. So when it is 8 p.m., your rate of entries is at 2300s. So then looking at your rate that is processing this, you have P of T. So what is left by the time it is midnight at T equals 12 is simply going to be the 23, that is what you have at 23 hundreds of entries at 8 p.m., minus the integral from 8 to 12 when you stop processing it, P of T dt. So with this situation, you're going to have to use your TI-84 calculator. You're going to have to calculate this piece right here using this equation. So we're going to go to math 9, which is your integral. You're going to put down 8, 12, and then type this into that box, and then dx, and then hit enter. So then when you do that, you should have 16 right here. Don't forget 23. What's 23 minus 16? That does give you 7 hundredths of entries left. That, and again, I always like to go back to the question so I can rephrase it. You could say left that had not been processed. So for part C, it is 2 points, 1 for the integral, 1 for the correct answer. All right, part D. According to the model from part C, at what time were the entries being processed most quickly? Justify your answer. Okay, so when I think about process most quickly, P of T is telling you how much entries or how many entries is left. If it's being processed most quickly, I'm thinking about critical point. So then first what I have to do is to find P prime of T. To figure out the critical point, I set it equal to 0, solve for T, and that's going to give me my critical point, which is going to test for max and min. P prime of T is going to give me a 3t squared minus 60t plus 298. Set it equal to 0. Now, if you don't want to factor this, that's fine. What you can do is you can go ahead and graph it. On your TI-84, hit graph, Y1, graph that, and then you need to find the zeros, in which case you hit second, calc, and then zeros to find those 2 critical points. And you know there's 2 because it's a quadratic formula, it's a quadratic, so you're gonna have 2 points. And so when you do that, you're gonna find out your critical point 1 is gonna equal to 9.18303, which is a time when there is a max or min because the slope is at 0. Your critical point 2 is going to be at 10.816497. And so from there, we're going to do a table to test out which one has the highest number for the y values. And so we're going to have t, which is going to equal our critical point, so 9.18, 10.2, or excuse me, 10.82. But in addition to that, you also need to include your endpoints. And the endpoint is going to be the time between 8 to 2. So put the 8 there, 12 here. This is going to be your P of T. And what we're looking for is the highest value, because that will indicate the maximum time that the entries were being processed. So what you can do with this is we are going to go back to this formula and plug in 8, 9.18, 10.82, and then 12. And so you could do this one of several ways. You can go ahead and graph this and then do a second calc X value, which I think will be the fastest. So using your TI-84, make sure you graph Y equals, and you're going to be putting this formula there. Second calc X value. And then you're going to type in the X values, and there are 4 of them. 8, 9.18, 10.82, and then 12. And once you go ahead and do that, you should find that 8 is going to give you a 0, 9.12 is 5.089, 10.82 is a 2.9, and 12 is 8. So which one here has the biggest value? Right there. So then what you can say here is the entries are processed. And again, I like to go back to the question. Entry being processed quickly, or most quickly, are processed most quickly at T equals 12. All right, you guys, so that is your second part right here. Which, if you take a look at the grading for this, it is worth 3 points. Find the critical point, identify the candidates, which are these 4 right here, and then justify your answer. All right, I'm gonna have you guys go ahead and take a look at the side right here. This is another question from 2008, and as you can see, a lot of these questions are getting just very, very repetitive, in my opinion. So this is another good one. I would like you guys to go ahead and try this one on your own. If you would like to watch the video, I have the link right here or the QR code, and then I also have what the other students in previous years have written about this question. All right, you guys, as always, I hope you have a wonderful week, and I'll see you guys next time.